According to the National Electrical Code, Article 300.4, B states that electrical conductors installed within or under the ground must be installed in a raceway, such as a conduit or duct. Article 550.10 B2 states that service entrance conductors, or SECs, must be protected from physical damage and must not be installed closer than 600 mm or 24 inches to the edge of the driveway or parking area. In this case, the SEC are located within 6 meters of the edge of the garage foundation wall, which is likely within the driveway or parking area. The SEC are not installed in a conduit or other raceway, which leaves them exposed to physical damage from vehicles or other objects. Therefore, the installation of the SEC in this manner does not comply with the NEC. They should have been installed in a conduit or provided with some other means of protection from damage. Potential consequences of non-compliance include physical damage to the SEC, which can lead to electrical hazards such as short circuits, fires, or electrocution, violation of built-in codes and safety regulations, which can result in fines or other penalties, and reduced property value or difficulty in selling the property due to safety concerns. It is recommended that the SEC should be relocated and installed in a conduit or other approved raceway, according to the requirements of the NEC and local building codes. This will ensure the safety and compliance with regulations. The National Electrical Code, or NEC, sets the standard for safe electrical installations. It is not law itself, but it is widely adopted by states and municipalities, becoming legally enforceable. When dealing with service entrance conductors, the NEC prioritizes protection from physical damage for several reasons. Firstly, exposed or inadequately protected conductors can be easily damaged by vehicles, tools, or even accidental contact. This damage can compromise the insulation, leading to short circuits, ground faults, and potentially fires. Secondly, damaged conductors pose a significant risk of electrical shock. If the insulation is compromised and a person comes into contact with the energized conductor, they could suffer severe injury or even death. Thirdly, compliance with the NEC ensures the long-term reliability and safety of the electrical system. Proper installation and protection of service entrance conductors minimize the risk of future problems and ensure that the system operates safely and efficiently for years to come. When assessing the installation of service entrance conductors, several factors need to be considered. 1. The location of the conductors relative to driveways, parking areas, and other areas where vehicles are likely to be present. 2. The type of protection provided, such as conduit, rigid metal tubing, or other approved raceways. 3. The depth of burial, if the conductors are installed underground. 4. The presence of any potential hazards, such as sharp objects or corrosive substances. When service entrance conductors are deemed to be inadequately protected, corrective action is necessary. Firstly, installing a conduit or other approved raceway to provide physical protection. Secondly, relocating the conductors to a safer location away from driveways and parking areas. Thirdly, increasing the depth of burial for underground conductors. Fourthly, repairing or replacing any damaged conductors or insulation. Choosing the right type of conduit or raceway is important for providing adequate protection. Rigid metal conduit, or RMC, is a heavy-duty option that offers excellent protection against physical damage. Intermediate metal conduit, or IMC, is a lighter weight option that provides good protection at a lower cost. Electrical metallic tubing, or IMT, is a thin-walled conduit that is suitable for use in dry locations where it is not subject to severe physical damage. PVC conduit is a non-metallic option that is resistant to corrosion and can be used in underground applications. The NEC provides specific guidelines for the installation of each type of conduit or raceway. These guidelines cover factors such as the minimum size of the conduit, the spacing of supports, and the type of fittings that are required. When installing conduit or raceway, it is important to follow these guidelines carefully to ensure that the installation is safe and compliant. In addition to physical protection, service entrance conductors must also be properly sized to carry the anticipated electrical load. The NEC provides tables and formulas for calculating the minimum size of conductors based on the load requirements of the building or structure. It is important to consult these resources to ensure that the conductors are adequately sized. Overloaded conductors can overheat, leading to insulation damage, short circuits, and fires. The NEC also requires that service entrance conductors be properly grounded. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Proper grounding helps to protect against electrical shock and minimize the risk of fire. The grounding system must be installed in accordance with the NEC requirements. This includes the use of grounding electrodes, grounding conductors, and bonding jumpers. Regular inspections of electrical systems are essential for identifying potential problems and ensuring continued safety. Inspections should be performed by qualified electricians who are familiar with the NEC and local building codes. During an inspection, the electrician will check the condition of the service entrance conductors, the grounding system, and other components of the electrical system. Any deficiencies that are identified should be corrected promptly. Homeowners and building owners should be aware of the potential hazards associated with inadequately protected service entrance conductors. They should take steps to ensure that their electrical systems are safe and compliant with the NEC. This may involve hiring a qualified electrician to perform an inspection and make any necessary repairs or upgrades. By following the guidelines of the NEC and taking appropriate safety precautions, it is possible to minimize the risk of electrical hazards and ensure the safety of people and property. Consider the long-term benefits of investing in proper electrical safety measures. Preventing electrical hazards not only protects lives and property but also avoids costly repairs, legal liabilities, and increased insurance premiums. A well-maintained and compliant electrical system adds value to a property and provides peace of mind. The NEC is constantly updated to reflect new technologies and best practices. Staying informed about the latest changes to the code is important for ensuring that electrical installations are safe and compliant. The NEC is published by the National Fire Protection Association, or NFPA, and is available for purchase online or at bookstores. Many resources are available to help people understand and comply with the NEC. These resources include training courses, seminars, and online tutorials. Consulting with a qualified electrician is always a good idea when dealing with electrical issues. An electrician can provide expert advice and ensure that electrical work is performed safely and correctly. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Understanding the basic principles of electricity can help people to be more aware of potential hazards and to take appropriate safety precautions. Electricity always seeks the path of least resistance to ground. When a person comes into contact with an energized conductor, their body can become part of the electrical circuit, resulting in electrical shock. The severity of the shock depends on the amount of current flowing through the body and the duration of the contact. Even a small amount of current can be fatal. Electricity can also cause fires by overheating conductors or igniting flammable materials. Overloaded circuits, loose connections, and damaged insulation can all contribute to electrical fires. It is important to be aware of the signs of electrical problems, such as flickering lights, burning smells, and hot outlets. These signs may indicate a potential hazard that needs to be addressed. Never attempt to repair electrical equipment or wiring unless you are qualified to do so. Electrical work should always be performed by a qualified electrician. When working around electricity, always use appropriate safety precautions such as wearing rubber gloves and using insulated tools. Never work on electrical equipment or wiring while it is energized. Always turn off the power at the circuit breaker or fuse box before starting any electrical work. By following these safety precautions, it is possible to minimize the risk of electrical hazards and ensure the safety of yourself and others. Understanding the NEC requirements for service entrance conductors is crucial for ensuring the safety and reliability of electrical systems. By properly protecting these conductors from physical damage, we can prevent electrical hazards and protect lives and property.